Our goal for today's lesson is being able to identify different function features given a graph. Here's the function features that we're going to be practicing with. The first one is the domain. The domain is identifying the function, where the function exists from left to right. These are the x values of your function. The range is where the function exists from bottom to top. These are the y values. Increasing and decreasing. To figure out where a function's increasing and decreasing, you trace the graph going left to right and see where it's going up versus where it's going down. Positive means above the x-axis. Negative means below the x-axis. Oops. And then the very last thing is the roots, the x-intercepts, or the zeros. These are all describing the same thing. These are x values where the function intersects the x-axis. So let's look at some questions. It says, determine the domain of the following function. So when we're looking at domain, we want to be thinking left to right. So if I go to the left side of this graph, since there's no arrows on it, here's where it ends on the left. Here's where it ends on the right. So what I want to figure out is, where does it start on the left? What x value? And where does it end on the right? What x value? So when I look at this, I see there's an open circle at -11. So my domain would be starting at an x value of -11, and it ends at an x value of 0. And since at 0, it's a closed dot, I need to use a square bracket. So that would be my domain. Now, if they asked you for the range is bottom to top. So we're going to go to the very bottom of the function and draw a line and go to the very top. There's no arrows, so I don't have to worry about it going to infinity. The range is the y values. So where is the bottom and the top on the y-axis? The bottom is at -2. I can see that's a closed circle, so I set up a square bracket there. And the top of the function is at 10. It's an open circle, so I go ahead and I use a curved parenthesis. So there's domain and range. The next thing, the graph of f of x is shown. What are all the real solutions of f of x equals 0? This is asking me to find what are called the zeros, because we're looking for where the function is 0. So we're looking for the zeros. These are also known as the x-intercepts. So my x-axis is here. If I trace along the graph, I see 1, 2, 3 places where it hits the x-axis. Those are the 3 places where the function is 0. We're going to write this as a solution set. So my solutions would be when x is -3, the function is 0. When x is -2, the function is 0. And when x is 1, the function is 0. So those would be my solutions, or my roots, or my x-intercepts. Here they want to know where the function is increasing. So when you're looking if a function is increasing or decreasing, you must trace the function going left to right. Don't look at the arrows, because you're going to think it's always decreasing. So you're going to start at the leftmost end of the function, and you're going to start tracing it. Well, if you think about what your pencil is doing while you're tracing it, my pencil's going up. So it's increasing right up to here. Beyond that, my pencil is going down. So I'm going to draw a vertical line right here because I know that's where it stops increasing and starts decreasing. Here's the tricky part. Because this graph keeps going down forever and ever, it's going down and it keeps going to the left. So when I talk about where it's increasing, it keeps going down into the left forever. So it's going to start increasing over here at negative infinity. And it's going to stop increasing when x is 5. And because the point at the top is neither increasing nor decreasing, you can either use a parenthesis or a square bracket. They'll accept either. You could also say that it's increasing when x is less than 5. Beyond that, if I keep tracing my graph, it's decreasing. So if I had to describe where it's decreasing, I would say it's decreasing from 5 to infinity. I'm writing with my mouse, so this has been a little tricky. Okay, next part, where it's positive. This means above the x-axis. So if I look at where it's positive here, whoops, and here. And if I were to draw a vertical line showing where it stops being positive, one of them would be here, and one of them would be here. Because this keeps going up and over, I know that it's going to keep going to the left forever and ever. Same with this side, it's going up and over, so it's going to be going to the right forever and ever. So if I want to describe this first interval where it's positive, which is right here, I want to describe it using the x values. And I would say that's from negative infinity, because again, it's positive over this chunk of the x-axis. So from negative infinity to -1. We do not include -1 because at -1, it is 0. And then where it's positive again is from 3 and going to the right forever. So from 3 to infinity. If we had to describe where it was negative, it's negative between -1 and 3. So there's positive and negative, above versus below the x-axis. Now this next one says, here's a function. What is true about the graph on the interval from A to B? So let's look at A to B. Well, first thing I notice is when I trace it left to right, my pen's going down. So that means this function is decreasing here. I also notice it is below the x-axis, which tells me it is negative. So it is negative and decreasing between A to B. If they asked you from B to C, we would say it's increasing, but we couldn't say it was negative or positive because it's both. It's negative here, and then it's positive here, but it's increasing there. Below F, it's negative and decreasing. Below A, it's decreasing because you want to trace it left to right, and positive. So just keep in mind those two concepts get mixed up all the time. So that's why we're going to spend a lot of time practicing this. Determine all intervals on which f of x is less than or equal to 0. This means where it is below the x-axis. So it's below the x-axis here. It touches 0. It stays below right up until here. Then it goes above. It's below again here. And it's below again here. So again, the arrows go down and to the left, down and to the right. So I'm going to probably be using my negative infinity and my positive infinity. If I look at where it stops being negative, it stops here, it stops here, here, and here. So the intervals I want to grab are where it's less than or equal to 0, where it's negative. So those intervals are here, here, and here. So now all I have to do is list those. This first interval on the left, whoops, is going to start at negative infinity. I got to see if I can find an infinity symbol. Negative, oh, there it is. Can I not? Oh, wait, there we go. Negative infinity to -3. And I'm going to include it because it wants to know when it's less than or equal to 0. And so it's less than 0. And then at -3, it's equal to 0. The next spot where it is less than or equal to 0 is between 0 and 3. And then the last spot is from 7 to infinity. So let's see, I should be able to put that in there. Oops, that's the wrong thing. So 7 to infinity, infinity always gets, whoops. Oh, that's weird. It made an exponent. Hold on. There we go. Okay. Infinity always gets a parenthesis. So these are the places where f of x is less than or equal to 0. And then the last thing is your absolute maximum. Absolute maximum is talking about the absolute highest this goes. Right here is your maximum. That's at 4. So I would say determine the absolute maximum. The absolute maximum is 4. Okay, that's the highest the function goes. So that's it for our function features. What you're going to do is if you go to Delta Math, let me open up the sample student page. When you go to Delta Math, you'll see this function features practice. That's what I want you to open up and work on. Okay, so there's a lot of practice here for you. It's going to take some practice. The places are easy to identify. The notation is the tricky part. Okay, thanks so much.